So if you're watching this, it means that my hard drive got wiped, and from Thursday slash this is possibly what we're doing for class on Friday, depending on whether or not I can get Zoom to work on the backup. So let's get going. So this is a review of what we learned at the end of class on Thursday. If you're one of the Thursday classes had in class slash this is what you missed if you couldn't make class. If you're one of the Friday classes, this is basically the gist of what I was going to show you on Friday. So we learned about z-scores. We know that a z-score, because you actually went through and looked at your notes, we know that a z-score gives us a measurement of how many standard deviations any particular data point is from the population mean. So for example, if I had a whole bunch of heights of a bunch of people, I could plug the mean for those heights in X bar, and I could calculate the standard deviation for those heights and put that in there for that lowercase sigma. And then if any Joe Schmo comes along and wants to know for his height, plug that value into X and we could calculate it for him. And that would tell us how many standard deviations above or below average his height is, right? So I believe the example that is in your assignments, that's the example we'll use today. I'm feeling nice, right? So we have the weights of newborn babies, if I'm not mistaken, at a hospital. It says the average weight for a newborn child was 3,200 grams, and the standard deviation 45 grams. Excuse me. What we can do, so I believe the question says, what is the probability of a child being born with a weight over 3,600 grams? Now, the way I want you to picture this, and I want you to get in a habit of doing this as well, right? So I want you to imagine anytime it's talking about a normal distribution, which in this case it is, I want you to draw a normal curve, just like that. I want you to imagine where the mean is. This is my attempt at a dotted line on this. And you go ahead and label it, right? So think about what it's asking, right? It wants to know the probability that a child is born at a weight of 3,600, which is higher than 3,200, or more. So it wants to know this side of the curve, right? So we want to know what this area is underneath the curve. So first, we need to know what z-score gets us there, and then we can take that z-score to a normal table and find the p-value or the proportion for that. Now, there's a trick that we'll have to know when we get there, but I'll go over that. So, excuse me. First, like I said, first we just need to calculate the z-score, right? So it's we want to know 3,600. What is the z-score for 3,600? Well, we take 3,600, subtract the mean of 3,200, and divide by the standard deviation of 375, which, quick little calculation will show us is 1.6, so 1.07 if we round properly. So that's the z-score for this. Now, that doesn't really tell us what we're interested in. We want to know the proportion of children that would be born with a weight higher than 3,600, or the probability of a child being born with a weight over 3,600. Those two are sort of interchangeable here. So what we do is we take this z-score of 1.07 and we go to our standard normal table and we find 1.07. To find this, I just Googled z-table or standard normal table. So we find 1.0 here. I can't write on this part. So 1.0, and then the second decimal place was 7. So 1.07, and we see the z-score, the p-value is 0.8340. Now I want you to pay attention to the picture at the top of this. Notice what side of the graph is shaded in, right? So we have 1.07. The shaded area represents 0.8577, or 85.77%. Now we were interested in this section over here. We want to know the probability that a child is born with a weight greater than 3,600, not less. Over here would be less, over here would be greater. So it's an easy fix. All we have to do is say, okay, well, if the left-hand side is 0.8577, and all of this stuff adds up to 1, which you would know if you looked at the notes, then 1 minus 0.8577 will give us this area over here. And that's exactly what we do. 1 minus 0.8577, or 0.24, no, I'm sorry, 0.1423. There you go. 0.1423, or 14.23%. And so that's the probability, that's a proportion that is under the area we're interested in. So I guess, well, no, if we're going to use complete sentences, proportion, just happened there, of then 3,600 grams is 0.14. There you go. How's that for handwriting, huh? Very good. Now, if that was tedious, fear not. There is hope for you yet. What we can do instead is say, okay, I don't want to do all that. And I know if I were in class right now, you would have some thing on the calculator that would do most of this for us. And you're right. There's a function on the calculator that I wish I could show you here, but my work computer is completely kaput. So I don't have the TI software on my home desktop. But it's called, you use a normal CDF on the TI Nspire, and you can plug in a mean and a standard deviation and just the information you're looking for, and it'll tell you exactly what the p-value is. It won't even make you calculate the z-score like we did up here. Now, luckily, there's web tools that will do this for us. We just have to Google correctly. So, just in case. There we go. Online stat book. Yeah, this was it. Okay, this is pretty dope. So all I have to do, my mean, if you recall, was 3,200. My standard deviation was 375, and I was looking for how much of the curve was above 3,600. Oh, not only does it give me the picture, it also tells me right there. Oh, 0.1431. I was close. I was very close. This is probably because I rounded, right? Well, what if I want to change that? What if I want to look below? Oh, you just click the below tab and hit enter. And it not only shades it for you, but it also tells you 0.8569. That's pretty awesome. What if I want to ask a more complicated question? What if I want to say, okay, well, what if it's between 3,400 and 3,600? I'll shade that for you too, and it'll give you the amount, the proportion, right? So you can get really specific with this. So this is nice. It saves us a lot of time and a lot of stress with trying to find that stuff in the table and doing all that. It basically says, okay, well, the proportion of babies that were born with a weight above 3,600 grams is 0.1431 or 14.31%, which is exactly what the question asked. And we did it by simply just typing this. So here is the thing that you're looking for. I'll put this link in the description so you can find this. And I'll try to remember to make Google Classrooms if I can even friggin' get into those. I don't even know if I can get into those right now. Probably. Now, what if we are asked a more specific question? What if, how do I clear? Is there a clear button? Clear everything? What if, instead, I get asked the question, okay, well, rather than finding me a p-value for a specific measurement, I'm going to give you a p-value, I'm going to give you a proportion, and I want you to tell me what measurement would give me that value. Which we can do that too, right? So again, we're still using the same formula, but let's say I want you to tell me, I think the question in your assignment is the 45th percentile, but for the sake of making it not super easy for you, let's just pick a different percentile, right? So let's say 35th percentile, right? So what would weight a little ableist talking about baby weights. We're not trying to shame anybody here. For the 35th percentile. Now, just a recap of what that means. The 35th percentile means, in this context, this baby is heavier than 35% of the other babies. So, in terms of our curve that we're interested in, that means this part of the shaded area would only be 35%, so it would be less than half. So what we do to start this, rather than start with the z-score formula, we're given a percentile, we're given a p-value. We need to find that p-value in this table and find the z-score that gives us that p-value, right? So, excuse me. So what we do instead, I mean, if you look here, this one starts at 0.5 and goes up to 0.98. That's not really helpful. We need something better than that. If we scroll, oh, here we go. Here's all of them. This is a small side. So if we say, all right, we need 0.35. Hold on, is this about to cut off? So we need 0.35. No, that's 0.035. 0.35. Where are we at? Where are you? I'm getting close. I can feel it. Oh, here we go. Okay, which one of these is closest? 0.3483 or 0.3520? This one is a little bit closest. But no, wait, we want at least the 35th percentile, right? So we want to be bigger than 35%. So we need the one that's bigger. Okay, so we're going to do it with this one, 0.3520, because that gets us just on the other side of the 35th percentile. We're gonna overestimate, right? So 0.3520, the z-score for that is negative 0.38. Okay, so now that we know the z-score, I say, okay, I'm going to say negative 0.38 equals some measurement minus the mean of 36, or 3200 rather, sorry. Still talking about the same distribution, that's the 3200 over 375, the standard deviation. And we can basically calculate that very quickly by doing inverse operations. We multiply both sides by 375 to get rid of the 375 on the bottom. And then we add 3,200 to both sides to get rid of that, and we'd be left with something that is in terms of grams. So that's pretty nice. Not too hard, right? It's pretty much the same concept. Now, the cool thing is, just like there was a web calculator to do this a lot faster, there is another one that'll do this faster. It's called the inverse normal distribution calculator. In the TI Nspire, it's literally called the inverse normal. So we'll search inverse probability. There we go. Probability calculator. We're going to use the same website because I like the way they show things. All right, cool. So we want the mean was 3,200 still. The standard deviation was still 375. So as long as we know those two things, we're good. And we want to know the area below the 35th percentile, so 0.35. Oh, there you go. If we wanted above, it would give us that. But we want below, it gives us that. So there is the measurement that gives us this percentile. Boom. Done. So I'll post both of these links in the description for this video. I'm also going to have to edit this down a little bit. This is a long video. Alright. So there's the one, there's the other. It's very easy. Now you have all the tools you need to do that last assignment if you haven't started yet. Great job. Go forth and conquer.